Hello, welcome students. Today we will be studying about the limit for the indeterminate forms. In the last two lectures you will be already had covered this limit and continuity as well as differentiability. We already looked at some of the numericals of the continuity and differentiability, but now let's focus for this topic, that is limit for indeterminate forms, and that is relevant as far as like BTech first semester examination, because this is the syllabus of mostly first semester examination mathematics. So before diving into the limit for indeterminate forms, we should be aware about the basic of the differentiation formulas, because that will be required in the L'Hospital rule. So let's first recall the some of the basic differentiations, that is x to the power n, e to the power x, e to the power x, ln x, and log ax. Can we say sin x, cos x, tan x, cosec x, sec x, and cot x, and similarly sin inverse x, cos inverse x, tan inverse x, and cot inverse x. Okay, and also sec inverse x, cos inverse x. Okay, so let me write down the differentiation of each, because these are the only differentiation that you will be needing in the L'Hospital's rule. Okay, so what is n x to the power n minus 1, e to the power x ln of e, this is e to the power x, ln x differentiation 1 upon x, and this is 1 upon x ln a. Okay, sin x differentiation cos x, cos a differentiation minus sin x, tan x differentiation sec square x, cosec x is minus cosec x, cot x. Okay, and sec x is nothing but sec x, tan x, cot x is minus cosec square x, and sin inverse x is 1 upon under root of 1 minus x square, cos inverse is minus of under root of 1 minus x square, tan inverse x is 1 by 1 plus x square, cot inverse is minus of 1 plus x square, sec inverse x is 1 by x into under root of x square minus 1, this is minus 1 x under root of x square minus 1. So only this much formulas is needed while solving the L'Hospital rule. Okay, so before diving into the indeterminate forms, let's first recall some of the standard limits. Okay, so definitely you have studied this in your intermediate examination, standard limits. So what are the standard limits? That is limit x tends to a, x to the power n minus a to the power n by x minus a, limit x tends to 0, sin x by x, limit x tends to 0, tan x by x, limit x tends to infinity, sin x by x, limit x tends to 0, e to the power x by x, limit x tends to 0, a to the power x minus 1 upon x, limit x tends to 0, ln 1 plus x divided by x, limit 1 plus x to the power 1 by x, x tends to 0, limit x tends to 0, 1 plus ax to the power 1 by x, and similarly limit x tends to infinity, 1 plus 1 by x power x, and limit x tends to infinity, 1 plus a by x power x. Okay, so these are the basic formulas we will be needing this. So the answer for this is n a to the power n minus 1, this is 1, this is 1, this is 0, this is 1, this is ln of a, this is 1, this is e to the power a, this is e, and this is e to the power a. So these are the only basic formulas you will be needing it in the solving the indeterminate form. So first let's discuss what is indeterminate form. and there will be 4 type of indeterminate forms in your syllabus. Okay, what are indeterminate forms? So indeterminate form is a example like if and see 0 upon 0 is a type of determinate form, infinity upon infinity is a type of indeterminate form. So we will be covering this as type 1. Okay, and in this basically we use the L'Hospital rule. We will be covering up one by one each. And second type can be 0 into infinity, third type can be infinity minus infinity, and fourth are like 0 to power 0 or 1 to the power infinity or infinity to the power 0 form. So basically in your academic perspective there are 4 type of indeterminate form: type 1, type 2, type 3 and type 4. Okay, so in solving the determinate form we mostly use the L'Hospital rule. What we try to do, we just try to convert this problem into this, we try to convert this into this, we try to convert this into this, and this is the easiest of all the forms. Okay, so let's first discuss about the form number 1. Okay, this is indeterminate form. Indeterminate form 1. And what is this? This is nothing but 0 by 0 or infinity by infinity form. So in this what we use L'Hospital rule. Okay, L'Hospital's rule. And L'Hospital's rule basically is differentiating the numerator and denominator. Let us say if there is two function fx and phi x are two functions of x. Okay, and let's say limit x tends to a, when we calculate this, is also 0, and limit x tends to a, phi of x is also 0. So can we say limit x tends to a fx upon phi x, can we say this is nothing but it's taking the form of 0 by 0, because as we already covered that limits, if there are two functions then correspondingly there will be division of limits individually. Okay, so can we say this is nothing but taking the form of 0 by 0, or maybe let us say if it is also given like this, if the fx limit is found to be infinity and phi x limit is found to be infinity also, and let's say if we are calculating the limit of fx upon phi x, and this is again taking the form of infinity upon infinity, and this is taking the form of 0 by 0. So whenever there is a possibility of 0 by 0 or infinity by infinity form, what we used to do, we used to we used to differentiate the numerator as well as denominator. So first order derivative and second order derivative. Let's say again putting the values, if the numerator and denominator are 0, then again will we differentiate this. Okay, but if both are not 0, then we won't differentiate it further. Okay, so this is the sequence of indeterminate form. Okay, so let me solve it. Okay, remember one thing, that before applying the L'Hospital rule, always check whether it is taking the form of 0 by 0 or it is taking the form of infinity by infinity. Okay, so let me do some numericals for you just to get the more clarity. So question number 1 is like this. Let's say the function is given as limit x tends to 0, x cube plus x square, and this is 2x cube minus 7x square. So basically this is asking you the value of fx, and here you can see limit is tends to 0. Okay, so what we'll do, we'll put the values as 0. So let's first check the values. Limit x tends to 0, so 0 is cube plus 0 cube upon 0 cube minus 7 into 0 square. So can we say this is nothing but taking the 0 by 0 form, and since it is taking 0 by 0 form, what we'll do, we'll apply L'Hospital. Okay, So we'll apply L'Hospital rule, and L'Hospital rule means differentiate both numerator and denominator as well. So let's first differentiate it. Limit x tends to 0. So what is the differentiation of x cube? Can we say 3x square, and x square differentiation is 2x. What is the differentiation of 2x cube? Can we say this is nothing but 6x square minus 14x. Now let's put the values again. So let's put the values again. 0 is 3 into 0 square plus 2 into 0, 6 into 0 square minus 14 into 0. Again it is taking the 0 by 0 form. So what we have covered that till 0 by 0 or infinity by infinity form is being achieved, we will be differentiating up to that level, and once 0 by 0 or infinity by infinity form is not there, we will stop at that moment. Okay, so again here you can see it's coming at 0 by 0 form. So let's differentiate it one more time. So limit x tends to 0. What's the differentiation of numerator? Can we say this is 6x plus 2, and the denominator is 12x minus 14. Again put the values of x as 0. So can we say 6 into 0 plus 2 and 12 into 0 minus 14. So this is 0, this is 0. Can we say 2 by minus 14? Can we say minus 1 upon 7 is the answer. Okay. And this question has been asked in GATE examination as well. Now let's practice some of the numericals too. Let's say limit x tends to 3, 2x square minus 7x plus 3, and this is 5x square minus 12x minus 9. So we have to calculate the limit at 3. Okay, so again first check whether it is satisfying the 0 by 0 or infinity by infinity form or not. So you can see 2 into 3 square minus 7 into 3 plus 3. This is 5 into 3 square minus 12 into 3 minus 9. So 3 square 9, 9 2 is 18, 18 minus 21 plus 3. So numerator you can see it's coming 0, 9 for 45 minus 36 minus 9. So again this is 0 by 0 form. So once there is 0 by 0 form, what we do? We used to differentiate the numerator and denominator as well. So what's the differentiation of the numerator? Can we say 4x minus 7, and denominator is 10x minus 12. Let's put the values. 4 into 3 minus 7 and 10 into 3 minus 12. So can we say 4 is 12 minus 7 5, and this is 30 minus 12, this is 18. So 5 by 18 is the answer. Okay. Now let's focus on two more numericals. Question 3. Limit x tends to 0, e to the power x minus 1 plus x square by 2, and this is x cube. Okay, so here we are checking the limit at x is equal to 0. So let's put the values. E to the power 0 minus 1 plus 0 square by 2, this is 0 cube, and we know that e to the power 0 is nothing but 1. So 1 minus 1, and this is 0. So again this is 0 by 0 form. See, earlier the expression was looking quite complex, but now this is taking the form of 0 by 0. We'll apply the L'Hospital rule. L'Hospital means we'll differentiate the numerator as well as denominator. So x tends to 0. Differentiation of e to the power x is e to the power x minus of 1 differentiation is 0. X is 1, and x square is 2x by 2. So this will be getting cancelled, and differentiation of denominator is 3x square. So what's your final answer? Limit x tends to 0, and this is e to the power x minus 1 upon 3x square. Let's put the values again. So again limit, let's again put the values. So can we say 3 to the power 0 minus 1 by 3 into 0 square. Again 3 to the power 0, 1 minus 1 0, numerator is 0, denominator is 0. So again it's taking the 0 by 0 form. So let's differentiate it one more time. So limit x tends to 0, e to the power x, and this is 6x. Okay, so let's put the values again 0. So e to the power 0, and this is 6 into 0. Okay, sorry, basically here is the mistake. we haven't differentiated this. This is 3x square, differentiation is 6x, so 6x का differentiation 6x, so this would be e to the power x by 6. So put the values of x is equal to 0, so e to the power 0 by 6, and this is 1, so can we say 1 by 6 your final answer. Okay, let me solve some few more questions. Okay, limit x tends to 0 and 1 minus cos x divided by x square. Okay, so let's put the values at 0. So 1 minus cos 0 divided by 0 square, and cos 0 is nothing but 1, so again 1 minus 1, this is 0, again this is taking the 0 by 0 form, so it's taking the 0 by 0 form. Then what we'll do, we'll apply L'Hospital rule. So L'Hospital rule is limit x tends to 0, so 1 का differentiation 0, cos x का differentiation minus sin x, and this is 2x. So can we say limit x tends to 0, this is sin x by 2x. Okay, and if you recall the result, though there are two methods, either you can apply the direct result, because we know that limit x tends to 0, sin x by x is 1. Okay, so what you can do, there are two methods possible. Let's method number 1, method number 2. So 1 by 2 taking constant, can we say this is nothing but taking the form of this, and the value of this is 1, so answer is 1 by 2. Or the second method is put the values as 0. So limit x tends to 0, can we say sin 0 divided by 2 into 0, and sin 0 is 0 and this is 0, so again this is 0 by 0 form. So what we can do, we'll differentiate the numerator and denominator as well. So what is the differentiation of sin x, can we say this is cos x, and differentiation of 2x is 2. Now let's put the values. So cos 0 divided by 2, cos 0 is 1, so answer is 1 by 2. So from both the methods you can see the answers are same. Okay, so let's now move on to two more numericals which are a bit higher level. Okay, so the question given as limit x tends to 0, x into e to the power x minus log of 1 plus x divided by x square. So first check whether it's 0 by 0 form or not. So let's put the values as, we are checking the 0 by 0 in the right hand side. So can we say 0 e to the power 0 minus log of 1 plus 0, this is 0 square, so this is 0 and log 1 is 0. Okay, 0 0, so can we say this is nothing but taking the 0 by 0 form. Okay, so 0 by 0 form is there. What we'll do, we'll just differentiate it. So limit x tends to 0. Okay, and now we can see this is there are two terms. Okay, there are two terms, so how do we differentiate? Let's say if there are two functions, so how do we differentiate? We first take the constant and differentiate the second, and take the second as constant and differentiate the first. So similarly, d by dx of x into e to the power x will be, let's take x as constant, and d by dx of e to the power x, and take e to the power constant and d by dx of x. So can we say the differentiation of this is e to the power x, and differentiation of this is 1. So what's your final answer? X into e to the power x plus e to the power x. Okay, so differentiation of this is x e to the power x plus e to the power x, and log 1 plus x का differentiation, log x का differentiation of log x. What is differentiation of log x? This is nothing but 1 by x. So here 1 by x plus 1, so this will be 1 by x plus 1, and further differentiation of 1 by 1 plus x is 1. Okay, x square is nothing but 2x. Okay, now again put the values 0. So again you can, when you will be putting the values, can we say 0 into e to the power 0, e to the power 0 minus 1 by 1 plus 0, this is 2 into 0. So this is 0, this is 1, and this is 1. So again numerator is 0, denominator is 0. So what we'll do, we'll just differentiate one more time. Okay, so limit x tends to 0. From this, what's the differentiation of this? We have already covered here. So x e to the power x plus e to the power x, we have differentiated this term, now it's this term. So e to the power x differentiation is e to the power x itself, and what's the differentiation of 1 by 1 plus x square? Can we say this is nothing but minus 1 by 1 plus x ka whole square. So minus minus will be multiplied, and can we say this is nothing but 2x ka differentiation x. So limit, the final expression lies this: x e to the power x into 2 into e to the power x plus 1 divided by 1 plus x का होल स्क्वायर, एंड दिस इज़ 2x है तो यहाँ पे 2 होगा, दिस इज़ 2. ओके, नाउ लेट्स पुट द वैल्यूज. सो 0 इंटू ई टू द पावर 0, 2 इंटू ई टू द पावर 0 प्लस 1 बाई 1 प्लस 0 का होल स्क्वायर डिवाइडेड बाई 2. दिस इज़ 0, दिस इज़ 2. So 2 plus 1 divided by 2, and then we say answer is 3 by 2. Okay, now let's move on to the